Hi. Okay. Let's get started. This is Unit 3. This is I don't know what number time I've tried to record this lecture. Let's see if I can do it without crying at this point. Okay. Scatterplots, correlation and causation. So in this lecture H, there will only be 3 lectures in this unit. That means 3 attendance quizzes, 3 homeworks, 1 quiz, and 1 exam. Okay, so enjoy the break here. All right. So excuse me. Okay, so what we're going to do is we're going to kind of lay the foundation for the work that we're going to do in the next 2 sections. Okay, so we're going to talk about scatterplots, and scatterplots is going to be the tool that we're going to use to indicate what type of data we have. In other words, what shape our scatterplot takes on will give us an idea of what um, type of regression formula that we'll use in the next 2 sections. So I don't want to get ahead of myself. Like I said, I've tried to record this several times, and now I'm just going to keep it very much to the content here and not talk outside of what I have the content to be. Okay, so let's get started. First off, variables. We've used variables in the last unit. In the last unit, we were dealing with single data sets, kind of like the hamburger problem, the hamburger weights of the hamburger meat, or the cost of the peanut butter jars. Okay, that was single data. That was not 2 pieces of data on each thing that the data was collected on. Say each store, we didn't look at the price of peanut butter and the price of jelly and carry them as 2 units together. We only looked at the price of peanut butter. We only looked at the weight of the meats. Here, what we're going to do in Unit 3 is we're going to be using something called bivariate data. And bivariate data is data that has 2 components in it, like age and weight, or year and population of a particular place, or something like that. So we're going to be dealing with bivariate data, and I'll talk about that a little more. What I do want to talk about here is qualitative and quantitative data. There will be a question on your exam that asks that you'll have to define qualitative or quantitative data. On your Unit 3 exam, there will be a section of multiple choice. It's not a lot of multiple choice questions, just really the key terms and ideas that will come from this entire unit. So I want to tell you right now up front, qualitative and quantitative data will be on that test. Okay, now qualitative data is categorical data. Examples of qualitative data would be something like eye color, gender. And when you think about qualitative, and DER, I know, GEN, look at how I spelled gender, y'all. I am losing it. Losing it. Gender. Color of car. Make, model. These are all things that don't really come with a number, but we can categorize people as Ford people, Jeep people, Dodge people, Toyota people, right? We can categorize them like that. So anything like that could be a characteristic that is not numerical is going to be considered qualitative data. And then the other one is numeric, quantitative data like weight, population, things that are expressed in numbers, right? That's what it means to be numerical, expressed in numbers. Those are going to be the quantitative kind of data. Now, like I said, we're going to be using bivariate data in this section, and that means that it is two different variables that are obtained from the same population or sample. Okay, so we'll get two bits of information that'll be connected, related to each other. Okay, now when you're dealing with qualitative variables, it is very, very difficult. There are lots and lots of things that you have to do, stuff called cross tabulation. You have to convert those qualities into some sort of numeric scheme so that you can actually do math on them. So we're not doing any of that. We will not be dealing with qualitative variables at all. Okay. What we will be doing is we'll be using quantitative bivariate variables, and those will be expressed in ordered pairs. And I know you all had algebra before you got out of high school, and you know what the X and Y Cartesian coordinate plane looks like. You got your X value and your Y value, and that's what we're talking about. We're talking about, you know, plotting a point right here that would be X, Y, where X is the horizontal and Y is the vertical. And that's what we're kind of getting at. Now, a couple things that are very important for you to be sure you understand. X, the first in the point, the first in the pair, X, that is the independent variable. And that means independent. That means that it drives the dependent variable. So if we're talking about number of units sold at a fair booth versus the amount of money they brought in, okay? The independent variable there would be the number of units sold. The dependent variable, in other words, the one depending on how many is sold, is how much money they made, right? So that depends on the quantity of the independent variable. And that's an important nuance to understand when you're dealing with word problems and you're setting things up and deciding what their coordinates are, which one is X and which one is Y. It makes a difference in the way that you calculate these things, okay? So X is the independent variable, Y is the dependent variable. Now, the way we display this stuff is using a scatterplot graphs, and we'll talk about this here in a minute with the calculator, but let me get to the rest of the talk stuff, the rest of the definitions. And here we're going to talk about correlation and causation. And surely, whether you understand what those terms mean or not, you probably have heard that somewhere along your life. If you ever listen to the news or, any sort of, technical talks or anything like that, psychology talks, things like that. Correlation just means how close the data appears to be related. Now, correlation does not inform causation. That means just because data looks like it's related to each other, we cannot say that one thing caused the other. Okay, and there's a lot of reasons behind that. I'm not going to get too deep in the details, but I am going to get a little bit into the details. But first, let's look directly at correlation. Okay, and as I said, correlation is how tightly grouped is the data. And there's two main kinds of correlation. There's positive correlations where when you look from left to right at the data set, as you can see here, you can see I've tried to teach this before and left some marks. I missed that. But if you look to see here, you can see that these guys are going up in the positive direction when you look from left to right, but this one's flat. This is no correlation. Now we can see here that these guys are going up in the positive direction. And if you look at these at the bottom and you look from left to right, you're going downhill, right? And if you're going downhill, you're going in the negative direction. So these are positive and these are negative. Now there's two things we use to describe a correlation. We describe its direction. So positive and negative is the direction of the correlation. But the other thing, it would be the strength. There's also the strength, and the strength is going to be anywhere in the continuum, meaning any degree in between weak to strong. And it could even be very strong. Okay. However you want to interpret that. Okay, so if I was to look at these two guys here and I wanted to throw that piece in here, I would say that this is a strong positive correlation, because if you notice here, the data points, these little points on the graph are pretty closely grouped together. I mean, they're kind of like going together like a herd of animals might be going in the same direction, okay? And if you look at this second one here, you could call this weak. You could say it's kind of moderate. I don't know if we didn't have that line going in the middle there, we would necessarily see that it was trending up and in a positive direction, but you can kind of see it like in here and in here. But because it's not all very close together, I would call this weak, or another one I like to say is moderate. Like you can see it, but it's not super strong. Okay. And then I would say the same thing down here, that the first one, y'all, brain says no. Let's try it again. Strong. And this one will be weak. And as you look here, you can see how tight those dots are to each other. Ignore the line there. That just came on the graphic and I didn't take it off, but notice how close together that grouping is. Okay. So that talks about correlation, but what about causation? Well, causation is the cause and effect relationship. It's pretty straightforward. You can focus on the situation, the effect, like what happened, like poverty, and try to find the causes of poverty, right? So you can always start out with what happened and figure out the why. That's usually the way that it works. It's often not very possible to have that foresight to see when you apply some sort of treatment to a group, when you apply something new, like say we all of a sudden everyone had to drink a special kind of water, or something like that, you could make some sort of guesses on what might be the effect, but until there are people with increased, and I don't know, I'm just making this crap up so y'all know that I'm making this up off my head, okay? But say that there's like an increased instance of stomach cancer when everybody changes to super alkaline water or something like that, right? But they didn't say, hey, if you drink all this alkaline water, we know that the effect is going to be all this stomach cancer. It's more like there's a big group of stomach cancer and they're like, oh, what caused that? That's that cause and effect, right? And so to determine the cause of something, you ask yourself why it happened. And to determine the effect, you ask yourself what happened. Okay. And that's often a confusion there. The effect is what happened and the cause is why did it happen? And in my really crappy example here, the what happened would be the stomach cancer, and the why it happened would be the alkaline water, which again, I just don't know why I even made that up in my little brain. Okay, let's keep on going. Now, another thing here that's really important, and this is just for you to be a good citizen, for you to be a good adult, understanding some of the information that's disseminated to you from lots of different sources. There's something called lurking variables. Now, there's one thing you may have already heard in your life because people say it all the time. And with statistics, you can manipulate the data and get any kind of statistics that you want. And it is true. It is true. And so it's very, very important for you to always meet statistics and things like that with a very critical eye. And one of the main things, and the main things that makes that true, is things called lurking variables. Okay. People like to make very big and broad statements about a certain thing, like maybe the how good a particular kind of cleaner works on a situation, or it always works good, but it turns out that they only ever tried it on one kind of stain or one kind of situation. So a lurking variable is a variable used to explain why you can't depend on the strong relation in a correlation to determine a causation. And I've got an example here, and this is a good one, right? Uh, there's a there's a good example of this phenomena, and it's that there's a super strong relationship between the amount of fire damage done at a house fire and the number of firefighters that show up to battle the blaze. Now, that seems very like one of those, duh, of course. Why are you wasting my time telling me that? But the truth is that that's not necessarily true, because there's actually a lurking variable there. There's the size of a fire. And you need to think that completely through, or the causes of the fire. So the size of the fire is a lurking variable. It causes both the amount of damage and the number of firefighters. And so it kind of muddles everything. So you just need to be critical when you read things like this. And you also want to always ask yourself, as I always do, what is the motivation of the person that's trying to tell me this information? All right, let's keep on going. Finally, to the math stuff and not all my blathering. Let's get this done. I think I only have like 4 examples for us to do. Now, the first thing I want to point out, pardon me, is that this table is done in a horizontal manner because it was easier for me to format that way, and it didn't take up very much room. But you will often see the format given to you in a vertical table as well. And one of my examples will be a vertical table, but I wanted to take a moment here. I also need to take a moment to give you today's silly phrase. Okay, so let me take a drink of my water here. Make sure you have your pencil ready to write down today's phrase. And the silly phrase for lecture H is, I found a unicorn coupon for a free coffee. Okay, I found a unicorn coupon for a free coffee. Okay. All right. So that was our phrase. We're done. Let's get back here. Let's talk about scatter plots. All right. So we're going to be doing this on the calculator. There are very specific steps to do so. and I hope that you have your calculator with you. If you do not have your calculator with you, if you haven't gotten one from the library, you should go get one so you can practice. If not, please be sure to pull up your calculator just like this online calculator, and do this with me. Now, here's our first example. An experimental psychologist asserts that the older a child is, the fewer irrelevant answers they will give during a controlled experiment. Okay, so like if you're sitting down asking them questions, sometimes a kid might say something that's completely irrelevant to the question that you ask, and that's what they're kind of studying here. All right. To investigate the claim, the following data was collected, and you see here, let X be the age of the child, and that means that the age of the child here is dependent. This is the dependent variable. The independent variable, y'all. If I had the time and energy to edit this, I would edit that out. Please, this is the independent variable. This is the variable that drives the data. This is the variable that gives us the output, right? And the output is, the Y is the dependent variable. And you can think of it kind of like the output. Okay. Now, let me show you how we're going to do this. I do hope you have your calculator. Please pause this video if you don't have it all set up, and then set it up, because there's a one-time setup for your calculator to do this correctly. Okay, you don't have to do it every time. So once I show you this one-time setup, I won't be, pardon me, showing it to you again. Unless asked. Okay. All right. So first thing first is we need to set up the ability to do a stat plot. Now, I think we talked about this last time. Oh my gosh, now I'm going to cough like crazy. Okay. We may or may not have talked about this yet, about these graphing calculators. I'm just going to go ahead and say this. If you need to do anything in the blue text or anything in blue, you have to hit the second button first. So first things, we've got to turn on our stat plot. Okay. So we're going to go second, Y equals, and that pops up this screen. And here we have stat plots, and notice that these all say blah, blah, blah. And if you go all the way down here, it turns them all on. I do not suggest you do that, because it could get very, very messy for you. So what you want to do is you want to enter into the first one. Now this gives you a lot of information here. We can turn on the plots on and off. We've got different types. Yes, there's different types. It is going to default to what we need, which is scatter plots. So we're good there. We don't have to do anything with the types, but yes, it will do histogram. Yes, it will do box and whisker plots. Okay. Then it has our two variables. We have our X list and our Y list, and this L1 and L2 is going to refer to the lists in the stat section that we used last time. But now, instead of putting it all in one, we're going to use the L1 and L2 and put in this paired data. So it's going to be very similar to what we did last time, but we're doing something completely different. Okay. You can also change what kind of a symbol that you want to use. You're going to have to use the arrow keys to come down here. I think I'm going to use a cross. And we can also change the color if you're so inclined. And let's just choose green. So I'm going to go back up here. Right now you see that it is plots off here, right? I'm going to go back up here, and I'm going to hit the enter And now it says the plots are on. And now anytime you're anywhere on your calculator and you can't get back home, like this is in some sort of thing, if you hit enter, it doesn't help. If you hit clear, it doesn't help. You have to go second and quit to get you back to the home screen. Okay, so here we are. We're going to do just as we did when we entered in our information for all of the stats that we did last time. So we can go here to stat and we are going to go edit. So we're going to enter. And now we have L1, so that is list one. L1 is for your X variable, and I don't think I can write on it with my pen or I would write over there. Let me just see just for giggles. No, I can just point with it with my pen. So L1 is your X, L2 is your Y. Yes, we could have lots and lots of variables here and do a whole bunch of work. We are only going to be dealing with bivariate data. So there's only going to be using L1 and L2. Okay, so turning our attentions back over here to the data we have. So this guy is our L1 list and this is our L2. And by the way, that is list 1 is X, list 2 is Y. Okay. And all I'm really asking you to do here is to just do it and kind of get comfortable with it. So I'm going to put in our list 1. You're going to go straight across, put in all of the list 1 values, and then you'll scroll over and put in all of the list 2 values. So here we have, oops, I can't use that. I've got to use this. All right, let's do it. 2, enter, 4, enter, 5, enter. Notice there's 2 6s, so 6, enter, 6, enter, 7, enter, 9, enter, 9, enter, 10, enter, 12. Enter. You got to hit enter or it will not collect the data spot, okay? Then you're going to use your little arrow wheel over here and navigate over to the next one, and we're going to put in the L2 data. So 12, enter, 13, 9, 7, 12, 8, 6, 9, 7, and 5. Okay. Now, you want to be sure that all of your data is matched up here, and I'll show you on the next example. I'll mess one of them up and show you what it'll say so you'll know what it'll look like, okay? But if you notice here, each line here has got 2. All right. Now, what we're going to do is we're going to hit stat. And now we're going to use, oh, sorry, my bad. I forgot what we were doing. My bad. Now we're going to hit zoom. So let me get us back to where we were. We were in stat and edit. The last time I left you, here we were, right? Okay. And now from here, you can hit stat again. And I screwed up again. That's the next lesson. Here we go. Stat, edit. Here you go. Now you're going to want to quit. You're going to go up here to zoom. And you're going to scroll down to zoom stat. I'm going to write these directions down. You're going to hit enter. And there you have it. Here is our scatter plot. So let me go back again because I know I kind of screwed that up. Let me second and quit. Okay, so first we go into stat. We go into edit. We enter in our list 1 all the way down. We enter in our list 2 all the way down, and we go second quit. Then we go zoom, and we go down to zoom stat and enter. All right, so let me write that down real quick. Get you some steps. Hold on a second. So first we go stat. Then we go to edit. And then you're going to enter L1 and L2. All right, and then you're going to go second, quit. And then you're going to use the zoom button. And you're going to go to zoom stat. All right, it's the 9th one down. You can also do the hotkey of 9. Let me show it to you one more time. So I can go zoom, and instead of me scrolling, click, 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 all those clicks, I can click the 9. See that 9 right there? Indicating which one. I can click that 9 and it brings it right up. Okay, it's kind of a hotkey for your calculator. Okay, now I think on the homework, and I'm not really sure, I didn't take a look before I started recording this. I think on the homework, I ask you to tell me whether it is a positive or a negative correlation, and if you think it's strong or weak or whatever. Well, first off, if we look from left to right here, we can see the data is going down. From left to right, you're going down the hill. That is negative. And I'd say it's moderately strong negative. So I'm going to say this is moderately strong negative correlation. Okay. Awesome. So here's one. Here's another one. I would encourage you greatly to pause the video right now. Just pause it and do it yourself and see where we go. Okay. But before you pause the video, hold on. Don't pause it yet. Don't pause it yet. Let me show you a little trick. L1, L2. Okay, here we go. So we're in our scatter plot over here. So we need a second quit out of that. We've got a new set of data. Here is our X values, hours slept, our Y values, the grade on the exam. We're looking to see, is there a correlation maybe? Who knows what their study really is. Right now, all we're doing is going to plug this in and see what it does. So we're going to go to stat. We're going to go to edit. Now, you can do one of two things. You can just rewrite over the stuff or hand clear it. Do not use the delete. Do not use the delete. But you can come up to the title and it gives you all of the elements in that list, and you can clear that whole list in one shot. Okay? But if you hit delete, it will go away. Let me show you. I'm going to go over here and I'm going to hit delete on one that I don't care about because I don't want to mess everything up. But I'm just going to go over here to like number 4. And I'm up here. Wait, let me put some stuff in it. Okay, if I was to come up here, sorry, I've got a touchscreen computer too, so it doesn't help here. Okay, if I'm go up here and I hit clear, it's going to clear everything out. Okay, check it out. But if I go up here, watch it, that's an L4, and I hit delete, L4 is gone. That's a big problem. Okay, so if that happens to you, then you're going to have a hard time here, and I'll show that mistake in a minute. Okay, so here we've got 8, 7, 7, 8, 6, 5, 7. 10 numbers, cool. Okay, and then I'm going to go over here, and these aren't the values we need, so I'm going to go up here and I'm going to clear out that list. We're not deleting the list, we're clearing out the list. So let me run it. Clear out list. Do not delete list. Okay. Hopefully that'll just save one of you from getting very frustrated. Okay, so there we go. Let's get these numbers in here. We have 83, 86, 74, 88, 76, 63, 90, 16, 8. Okay, so you want to make sure that you have all that data. Let me show you what would happen if you didn't have all that data. So let me just clear that one unit out. It doesn't want to, it's not going to let me clear it. It doesn't want to let me clear it. Should let me clear it. There it is. Oh, it's not going to let me screw it up. Okay. Anyway, all right. Let me show you another way. Just put another value in there. See, they don't line up first off. And what would happen here is if we went zoom stat, I think it's going to give us a problem. See, dimension mismatch. Dimension mismatch means that your data is mismatched. You missed one. You forgot probably to hit enter on that last one. It happened to me so many times, okay? So that's probably where the issue comes in, all right? So then what would you do? You'd say quit. You would go back here. You would look at your edit, and you would say, oh, what's up with that? I'm missing, there's one too many there. Let's go ahead and hit uh, clear here and enter. This might be a problem with the online. Sometimes when you're using online calculators, something jacked up can happen when you're trying to do something that's kind of odd. This is still going to be just fine. Let's just leave this as 8. And I will put in a number over here and we'll make it 84. Because I got to be matching. Now we're matching. Okay, cool. So I actually threw in, let me write it here. We put in an 8 and an 84 because this is going to change the picture. So I don't want you going back later and going, well, what happened? So let's do that. Okay, and now we can say zoom and zoom stat, and there's our picture. Okay, and you can see all that data there. That looks like it's a pretty pretty strong positive correlation, I'd say. Strong positive correlation. And of course, it's a strong positive correlation. That's between the hours you sleep and the grade you'll get on an exam. If you only sleep 2 hours, you're sure not going to get a great grade on your exam, no matter how hard you study. All right. Let's give you a you do. Yes, you do. Okay, I'm going to write the steps while you work on the you do. All right, so we're going to go. I do like to generally make a habit of clearing all my data before I start entering in anything, because that way, everything's clean. This is tedious, in the way that, uh, putting data in order or doing that standard deviation was tedious. You just have to keep your eye on it, pay attention, maybe use your finger to keep you in place. It's way easier to do this with a calculator than with the clicks. Also, just FYI, you really should go get a calculator from the library if you haven't. In fact, if we were having face-to-face class, you would all have a calculator. For sure. Okay, so see, these guys are all lined up. Everything looks good. We're going to jump here to our Zoom and down to our Zoom stat or hit the number 9. And ooh, wee, look at that. Super duper strong. I would say extremely strong positive correlation. Those data points are darn near on top of each other. Okay. All right, and we've got one more example. This is a regular table. You've seen these things before. This is what I was talking about earlier, that a lot of my tables in my slides are done horizontal because they fit better in the PowerPoint and they format easier. But you'll see in homework or you'll see in your science classes or your humanities classes, you'll see it given in a table form. Same though. Okay. So let's just jump in there and get this one done. Oh, anytime you land somewhere that you can't figure out where you are or it's awful, you just second quit. You can't get out of it, back out of it, delete out of it, clear out of it, do any of that. Second quit is the way to do that. Okay, so let's hit it up. Stat, enter. I'm going to clear. Enter in the data. Okay, I always look and make sure so I don't waste my time and have to go back. That looks great. So I'm going to go Zoom. We're going to go down to Zoom stat and there we go. Looks like a positive correlation. I'd say a strong positive correlation. Now, we've made it to the end here. I'm going to remind you that the phrase is I found a unicorn coupon for a free coffee. I found a unicorn coupon for a free coffee. Okay. And I'm also going to tell you that you are not really going to be telling me about positive and negative correlations and stuff like that beyond this particular homework. Moving forward in the next two sections, we will be dealing with word problems that have data and answering questions and making predictions on that data by using regression equations. And that's where we're going. So enjoy this little data entry thing. If you have any trouble, let me know. I'm available. Just holler at me in the email or show up at one of my 7 office hours a week. All right, you guys have a great day, and I will see you next time. If I can find where to stop this silly recording, I would be happy to. All right.